Assalamu alaikum wa rahmatullahi wa barakatuh and welcome back, my dear students. Today, inshallah, we are diving into another set of classified past papers questions for paper 2. Let's start. Bismillah. Bismillah. The first question we have here today, a metal ball is attached to a cork and is lowered into a measuring cylinder. Pulling the cork into the water as shown, the ball and the cork above the water, and the volume is 48 centimeter cube. This is the volume of the liquid only, the volume of the water we have. Ball fully submerged, but cork above the water, and the new volume is 56 centimeter cube. Both ball and the cork fully submerged right now, and the total volume is 80 centimeter cube. The mass of the cork is 4.8 gram. What is the density of the cork? We know that density equals mass over volume. So we need to find the density of the cork. So I need to find the volume of the cork, and already the mass of the cork is given. So what is the volume of the cork? I can find the volume of the cork between the two last measuring cylinder, because the only change in the level of the water due to the submerged of a piece of cork is between the second and the third. No need for the volume of the water in the beginning, or the volume of the sinker or the metal ball or whatever. So I'm going to find the difference between these two, and of course I'm going to consider the second and the third measuring cylinder, or the third drawing, or the third scene we have here. So 80 minus 56. So 80 minus 56 is what? 80 minus 56 equal 24. So 24 centimeter cube. This is the volume of the cork. And already we have the mass. So the density of the cork, mass of the cork, 4.8 over 24. It will give us 0.20 gram per centimeter cube. So the correct answer is letter B. The second question, a rectangular metal block is 20 centimeter long. Rectangular metal block, so with the length of 20 centimeter long. The cross-sectional area, we have the area of the block is 25 centimeter cube. So we can find the volume of the block. The mass of the block is 4,000 grams. What is the density of the metal block? Again, density equal mass over volume. We have the mass, which is 4,000 gram, and the volume is length, or the whatever the long of the rectangular metal block, multiplied by 25. So it will give us directly the density. So we have here 4,000 over 20 times 25. 8. So the correct answer is 8.0. Since all are two significant figures, so the correct answer is letter C. A square wooden raft. So we have a square wooden raft, so all the sides are equal. Floats on a lake surface. The density of the water in the lake is 1,000 kilogram per cubic meter. So density of the water is 1,000 kilogram per cubic centimeters, cubic meters, I'm sorry. Cubic meters. The sides of the raft are 2.0 meters. So all the sides are 2.0 meter long. And the thickness of the raft is 0.20 meter. So the immersed part is 0.2 meter. The mass of the raft itself is 700 kilogram. Okay, how many barrels, each of mass 100 kilogram, could be placed on the raft before its surface sinks to the surface of the water? Okay, guys, let's see here. Bismillah ar-Rahman ar-Rahim. We said we are going to find the mass, density equal mass over volume, rearranging the equation, making the mass the subject, mass equal density times volume. The density is 1,000, and the volume 2 times 2 Need the area by the thickness of the immersed part, 0.2. Let's find the result here. To find the mass of the water displaced by the immersed raft. So 1,000 times 2 times 2 times 0.2 equal 800. So 800 kilogram. So if the mass of the raft itself is 700, and the mass of the water displaced is 800, so actually whatever left is 100 kilogram. So 800 minus 700 will give us 100 kilogram. So we can add only one barrel before it completely sinks under the water. Question number 37. The diagram shows a stone of irregular shape. Which property of the stone can be found by lowering it into a measuring cylinder half filled with water? Imagine we have a measuring cylinder half filled with water, and we are going to fill it with, we are going to immerse this stone. For what? Actually, the measuring cylinder half filled with water, when we immerse an irregular shaped object like an irregular stone, we are going to measure its volume. So the correct answer is letter C. Which piece of apparatus is most suitable for measuring the mass of a pencil sharpener? Mass of pencil sharpener is very small, so measuring cylinder for measuring the volume, Newton's meter for measuring the weight, ruler for measuring the volume if it is regular, digital balance, of course, for measuring the mass of a pencil sharpener. So A is the correct answer. The diagram shows a plastic rod alongside a ruler. We have 0, we have 10, we have 20, and we have divisions. The difference between 0 and 10, we know that it's 10. 10, and we have 5 divisions, so each division length is 2 centimeters. How many? The length of the plastic rod? 1, 2, 3 and a half. So 3.5 times 2 will give us 7.0. So the length of the ruler is 7.0. Question number 40. What is the best description of the measuring of mass of an object? Mass of an object is the amount of matter in an object. Or we can define it as the inertial mass, the resistance of the object to change its motion or to changes in motion. So the correct answer is letter C. It matches the definition for the inertial mass, or the scientific definition for the mass. No need for reading the other. The space occupied by the object is the volume, the force that gravity exerts on the object is the weight, the closeness of packing of the molecules, its density. So C is the correct answer for sure. Question number 41. The mass of an empty flask is 34 grams. So M for the mass, M1, when it is empty, 34 grams. The volume of the liquid added to the flask is 20 cubic centimeters. So the volume of the liquid equal 20 centimeter cube. The total mass of the flask and the volume, so M2 equal 50 grams after adding the liquid. So the mass of the liquid actually will be 50 minus 34. So 50 minus 34. 50 minus 34 equals 16. 35. So 16 mass grams. So we are going to find the density of the liquid. Density equal mass over volume. Again, the mass is 16 over 20. So 16 over 20. 16 over 20 equal 0.8. So 0.8. If I wrote 0.8, it's one significant figure. I need to add 0 here to make it two significant figure to match with the other. So 0.8, don't forget gram per centimeter cube. So the correct answer is letter A. Let's move to question number 42. A measuring cylinder contains 40 centimeter cube of water. A stone of mass 94 grams is lowered into the water so that it is fully submerged as shown. What is the density of the stone? So we need to find the new volume. I'm going to magnify the drawing here. We have 70 and we have 80 and we have 10 division. So it's 76 centimeter cube. This is the new volume. And the first volume was 40. So 76 minus 40, it will give us 36. Okay, 36 centimeter cube. This is the total volume of the stone. And we is asking for finding the density. Density equal mass over volume. Again, so 94 over 36 will give us the density. 94 divided by 36 is equal to 2.6. So the correct answer, 2.6 gram per cubic centimeter. As we said, the calculator is tricky and they are playing with numbers. So be careful. Don't write the whole number and make the number match the significant figures given in the problem. The significant figures given in the problem here is 2 significant figures. 40 is 2, 94 is 2. So the answer must be within 2 significant figures. I'm telling you this because we are going to use it in paper 6 and paper 4 later while solving them. Question 43. The tank shown had the dimensions of 5.0, 4.0, and 4.0. It is completely filled with water of density 1000 kilogram per cubic meter. What is the mass of the water in the tank? Is asking for the mass. Density equals mass over volume. Rearranging the equation, making mass the subject, mass equal density times volume. The density is 1000 and the volume is 5 times 4 times 4. So I'm going to put them all on the calculator. 1000 times 5 times 4 times 4 equals what? 80 and 30, 80,000 kilograms. So 80,000 kilogram is accepted and it is considered as 2 significant figures. 80 here can be considered as its significant, or I can write it in scientific notation, 8.0 times 10 to the power of 4. 10 to the power of 4, power of 10 is not counted as a significant figure, so 8.0 is counted as significant figure. If we have all these numbers, since there is no decimal point, it can be either 1 significant figure, 2 significant figures, 3 significant figures, 4 significant figures, 5 significant figures, or are accepted. So if I'm going to take 2, it's okay. It is better not to write too many zeros, as we said, and write it within 2 significant figures, like in the example here. And that's it for today. Okay. And I wish you all the best. I hope you noticed how Cambridge repeats certain concepts and tricks. I want you to practice more, search about more questions and practice more. And if you face any problem, just contact me. I wish you all the best. Assalamu alaikum wa rahmatullahi wa barakatuh.